Yeah, here's my agenda. It's relatively basic, but quite packed nonetheless. I want to talk a little bit about what NVL is and where it came from, and then we're just going to write some code with it. My name is Clemens. I'm from the Bloom team, a software engineer for the last 5-6 years. And yeah, let's get started. So NVL, it stands for Neo4j Visualization Library, and its origins come from Bloom. So it used to be, or still is, the graph visualization engine that powers Bloom, has been like part of the core technology of Bloom since the start. Here's a very old screenshot from 2019, Bloom version 1.1. And the focus of it has always been like large-scale graph visualization. So the layout as well as the rendering is GPU accelerated, and it's always been focused on that. Other tools within Neo4j have their own implementations of graph visualization. And over the last few years, we've been trying to unify all that. And the idea had been to use Bloom's visualization engine across all Neo4j tools that have any kind of aspect of graph visualization. And yeah, that's what we've been doing over the last few years. And I'm happy to say now Bloom, which is now called Explore, still uses, of course, NVL, also Query, Data Importer, and other tools like the LLM Graph Builder all make use of the Neo4j visualization library. And it's been quite the journey transforming this core piece of technology that was only part of Bloom into its own library. There were a lot of different requirements from all the different apps, and finding that balance of having something that's can serve all these requirements, but at the same time have a common look and feel and be easy to use out of the box was quite tricky. I gave a talk about it at Nodes last year, where we went a little bit through the entire design process of NVL and the architecture of it and how we struck that balance. You can find it on YouTube on the Neo4j channel if you're more interested in the architecture of NVL. Basically, it comes down to 3 layers. So we came up with a base layer, which doesn't provide any interactivity. It just renders the graph and has graph layouts. All interactivity can be built up from scratch, and that has the advantage that you can build it in whichever way you want. So if you don't want kind of a traditional graph interaction experience, it doesn't come out of the box. You can just build your own, and we're going to look at that today, how we can do that. But if you want something that just works out of the box, there are many interaction handlers that are sort of ready to use, part as a different library that you can add. Also, if you're using React, there's some React wrappers. But for today's example, we've got to keep it framework agnostic. Yep, and so much for the introduction. Let's go straight to writing some code. So NVL is available publicly on NPM. So here we can see on NPM, we are currently at version 0.3.6. So it's still a bit early days, but it's ready to use and it's available for everyone. So we've got a little bit of introduction here. There is also an API documentation page, which has auto-generated docs for each exported class and interface and function and so on, and all the methods. So they're also available inline in code. And we have on Neo4j docs also a guide how to get started, a bit more consumable and in detail. There is also a link to boilerplates right here, which are projects that help you just get started from the ground up for React and for plain JavaScript. And for Vita and Webpack, we've got projects here. I'm going to use the Webpack one today, which is this one here. And I've already set that up here in Visual Studio Code. I've already installed the dependencies, which saved me 22 seconds. So yeah, let's have a look. Just double checking that everyone can still see my screen here, but it looks like, yeah, it's good. Alrighty, so here we go. This is the package.json file. We've got a start and a build script, Babel dependencies, Webpack dependencies, and of course, as the main dependency, the base library and the interaction handlers of NVL. The Webpack config is quite basic. We've got an index HTML file and load JavaScript with Babel. Babel is just a basic preset. The HTML file is got an app container here and loads the JavaScript file, which has a very basic implementation of NVL here. So we get the container, nodes array, relationships array, They have to have IDs and the relationships also from and to. They have to match all up and have to be unique, otherwise NVL will complain. And we also add a little bit of interaction here. So now if we run this, and add DevTools, here we go, I get a basic little graph. Yeah, and that's probably the fastest way to get started with a new NVL project, one of these boilerplates. So now I can start editing things. So in terms of graph, I can, manipulate the color, manipulate the size, its state of a node as well as different states, and so on. So here we go. This can all, of course, be looked up in the API documentation as well. So for example, for what kind of different properties the node's interface has, and so on. Yeah, but of course, what I really want to use is some real data, not this hard-coded graph. So we can look at that in a second. One thing I still want to mention also in terms of the background, it doesn't have to be a white color. It can be anything you want. Any styling that basically is added to the container that the NVL is rendered in. So I'll just stick that a little bit, something he already prepared in my notes. So if I add some custom border and gradient, here we go, that should work. Similarly, if I add any content inside that div, let's reload this, and yeah, I'm clearly not a designer, but yeah, you get the idea there. It's customizable in any way you like here. So yeah, but let's get some real data into this, and for that, let's go to Aura. So here in Aura, I already have an instance running called NVL nodes demo. If we log into it here, it's just the basic movie graph. It's an example graph you can find here under the example datasets. It's very small. It's got movie and person nodes, and here relationships are connected in which way these people and movies are connected. So you can see graph. You can see this is already NVL in action here in query. So now if I want to have this graph in my NVL application, let's go here. And there's this beautiful little develop button on my instance. And let's get the JavaScript driver. There's probably a lot of content out there already how to connect with the JavaScript driver to Aura. But I want to show it in combination with the boilerplate project here regardless. So yeah, let's just copy paste this piece of code here, create a new file in my project just to keep it nice and tidy, called connection, and I'll just paste that whole content right in here, tidy it up a bit. We don't need that as part of the functional scope. Let's move that up. And here this, let's export this. Okay, now of course I need my username and my password, which I was given when I created the instance. I have that here in my notes. There we go. Now all this function does is just getting the server info and telling me if the connection was successful or not. So if I now call this function here and have a look at my app, I can see that I have a successful connection. Lovely. So now with that, let's get fetch some data. So I ran this query earlier here in query. So let's just grab that, put that here, pass that through, and instead of now fetching the server info, I want to get a query. So let's go ahead and go here and say driver has an execute query method. Where I just pass in that query. Let's call this data. Log the data in the console, and then return the data as well. Okay, so now what I should get here in NVL is a beautiful result with records with a key P, because that was the cipher query that I ran had the path specified as P, and then my records should be paths with a start and end node and a segment. The segment has also a node and a relationship, two relationships. Sorry, two nodes, one relationship. So now this data format is of course very different to the data format that NVL expects, which in our case is a nodes array and a relationships array with IDs. And all the captions, colors, and so on have to be specified through these properties. So it's all quite a different format. So how do I get that? The driver has something called result transformers, which can be passed into the query, which is quite handy if you want to turn your result in any kind of data format. Here's a little example where it maps over all the records and then collects them into an object, or in this case a map. So now we can write our own mapping through all the records and adding them to the nodes and relationships array in a certain format, adding color, captions, and so on. But I don't have to start doing that from scratch, because NVL does provide me with a result transformer. So it comes from the NVL result transformer, comes here from the base library. So we can add that. And we can see here that when using that result transformer, we can basically pass the result straight into NVL. So now if we get the data this way, and we go ahead over here and say, I want this result right away, and we can move this, move this up, and this here. So now instead of the hard-coded one, I should get the nodes and relationships straight from this query. So let's see how that looks. Yeah, and we can see it's the same graph from Aura. It is, here's the result. We've got a nodes array and a relationships array with IDs from and to. And what it also provides me is a map with all the records from the driver by ID. So I can still look up all the original stuff here too. Because I will need that if I want to style anything. Right now I've got no captions, I've got no colors. It's all pretty basic and boring. So to do that, in my connections here, I can go ahead and let's start with something basic. Let's just say we want our relationship types to be the caption on the relationship. So let's create a new relationships array based on the relationships in the data, map over it. And now we can, through that map I showed you, access the original relationship record. And now add any data from that to it. So let's say we return what we already got, plus as the caption we want to be the type. So let's use this in our return. And here we go. Now we've got the type here. I can do the same for nodes. I'm not going to type that out from scratch. I got it here prepared already. So now I am iterating over the nodes as well. From the original record, get the properties and the labels, and depending on that data, adding a caption. I've got person and movie node, so I'm either going to use the person's name or the movie title as the caption for the node, and I color it green if it's a person node, otherwise I'll leave the default color. So this should hopefully work now. Yeah, here we go. Now I've got a beautifully styled graph, similar to what I have in Aura, and I can continue to work with that. Okay, just to quickly recap what I've done so far, we've got we used the boilerplate to set everything up, then added a connections file pretty much based on what we copy pasted from Aura. use the execute query method to fetch a result with the NVL transformer that comes from NVL. And a little bit of starting by iterating over the records, starting them accordingly, and then returning that. Okay, so now I want to, of course, add some interactivity, and let's completely start from scratch here. So let's remove these interaction handlers that we have already, and start with something very basic. So right now, as it is now, I have nothing. I can click, scroll, won't do anything. And in order to add interactivity from scratch, which is the same way how the interaction handlers do it, is I have to add event listeners to the container that NVL is rendering in. So let's do that. Let's add an event listener. Start something basic. Just a basic click event. Of course, if you use React or any other framework, you can use the on-click properties, or whichever way the events are handled. But at the end of the day, it's all about just using the mouse events. So now, of course, I'm getting my event, and that's all nice, but the pointer event, it has a lot of information, but it doesn't tell me what was actually under the mouse, because the source element is just the div that NVL is rendered in. But because it's all done in canvases, there aren't any elements in the DOM that trace to. So if I want to know what I'm actually interacting with here, NVL provides a method called getHits. If we have a look at the documentation here, we can see that this takes a mouse event and then returns me an NVL mouse event. This is NVL mouse event is basically a mouse event just extended with hit targets. These hit targets have nodes and relationships, which in turn have the original node that was hit plus a whole bunch of coordinates and points based on where the mouse was at the time, where the element was at the time, the distance vector, and so on. Or a whole bunch of context that might be needed to use the events. So now I believe there's an example here as well. If I use this, paste that here, from the file, save, and let's have a look. And now when I click here, you can see here I'm getting nothing. But if I click now here, I have a node plus all the content. Same if I click, let's say if I click here right on two relationships. So relationship of course works as well, but if I click two, I should get two relationships here. The closest to the mouse always being first. That's why it's a race, in case there are several elements overlapping. Okay, so what can I do with that now? With that information, I can start manipulating my graph based on how I'm interacting and the graph state. So let's say I'm getting the node that has been interacted with. So in case this array wasn't empty, if I do indeed have a node, then I can use the update elements in graph method to give an update based on ID. Color was selected, that's suggested here. So let's do something like that. So here's my nodes array. My ID is from the interactive node, and let's do selected print. Been very basic. And now I can. Oh, sorry, forgot to do one thing. I don't want to update any relationships. Here we go. Yeah, like I said, very basic, but this is how basic interaction is done from the ground up. And I can do that for any mouse event. So it could be a mouse wheel event, could be a mouse move event. Yeah, so now, moving the mouse just directly select stuff. It's not particularly useful, but I hope you see where this is going. And now I can start doing all kinds of things. So instead of updating the graph, I can update my application style. So containers style, for example. Let's do the cursor. I want to be a pointer when I am hovered over a node. And when not, I want it to be the default. Let's see. Here we go. And yeah, now it sort of looks like the hyperlinks, which I can of course do as well. So let's remove that log here. If I add another one with a click event, say, well, if there is a node click now, then go to URL based on that. Got something here prepped in my notes. There it is. So here, as you can see, if a node is clicked, then it creates a URL based on the Wikipedia search, uses the caption to go there. So if I click here, nothing happens. If I click on the node, there we go. So if now I want to be even more bit custom and want to have interaction dependent on where the mouse is on the node. So we can do that, of course. So here on the mouse move, we could go ahead then and say if use the distance property of the target. So distance. So if my distance is smaller than, let's say, 15, I want different behavior. So only on the outskirts do I want it to be a pointer. Inside, let's turn it into a move. And similarly down here, then I should make sure that this is only triggered when the distance is greater than or equals 15. So now I should get a different cursor in the middle of the node, and the clicking it shouldn't do anything anymore. Here we go. Yeah. So as this insinuates, I want this to be dragging, which I then can do by using. So let's first check that a mouse button is pressed. So if I'm moving my mouse and I have a button pressed, go ahead and drag the node with it. So I can use another method of NVL setting node positions for that. It's again ID based. So my ID is from the node that is interacted with, and the positions come from the mouse pointer in the scene, which also comes from the target here. So node dot pointer coordinates x, coordinates y. This can of course be cleaned up a bit too. So now let's see. If I go ahead and interact here, I can drag the node. On the outside, I can click the node. Yeah, I'm realizing my graph doesn't update according to the layout, doesn't update to my dragging. The set node positions has a boolean for that allows me to do that. So if I set this here to true, then the layout will update accordingly. So I can just set this to true, or I put it based on the event true. So let's say if I have the control key pressed as well, then I want my layout to move. Otherwise, it stays stale. Now if I press control together, everything moves. And of course, my interaction of clicking still works as well. Yeah, so this is sort of an example how you can kind of from the ground up build something very custom. And so far, we haven't even used any of the interaction handlers that come with it. We've just built it completely custom. On top of that, on top of the dragging nodes, we could also build, panning ourselves if we wanted. So now that we have the mouse move event already, say, well, if no mouse is under the cursor and I'm pressing a button while doing this, update NVL's pan. So we can say pan, and then let's keep this very basic event context. And whoops, sorry, feeling the time constraints a bit. I've got only 5 minutes left here. I don't know why. So this should give me like a very basic kind of panning implementation here. There we go. It's of course not perfect. And if I want this kind of to work completely with all the different caveats that need to come with it, I can just use the pan interaction handler like we had earlier. So I just import this from the interaction handlers here, gets initiated with an existing NVL class. And now I have panning out of the box right here. Same goes for zooming and a whole bunch of other things. Zoom interaction can also come from the interaction handler. Okay, now all my interaction I've done so far is just like interacting with the graph I have already here. Let's say I want to get some more data from Aura. I can of course do that as well, and because the IDs in my graph here in NVL match my database IDs, this is relatively easy to do. So let's go ahead here, say we have a double click event. I only want this to trigger again in the middle of the node, and instead of doing this, I would like to query some more data. So let's say on double click I want to expand the node. Let's quickly write a query. That would be, let's say, the connections between node A and B and the relationship R. And this is now again the node ID. Here we go, this is my query. Now let's get the connections by running this query through the execute query function we wrote earlier. I need to make this now async. This should already come back perfectly styled with nodes and relationships. So now if I add an update the nodes and relationships, I should be able to do just that. So now if I double click in the middle here, I get real data from Aura here straight into my NVL instance. I still would like a little bit more visual feedback from the graph itself. For example, it's a bit hard to see what came back and what was already there. So we could go ahead and say my relationships, I want them to all come back as selected. So let's quickly make that update here and return the relationship as it is plus selected is true. So now if I do that, yeah, I can see a little bit better what has been returned. There is also a fit method by NVL that focuses on things. Oh wait, sorry, I'm not the wrong line. So the connection takes a bunch of node IDs. So I need to map this to only have the IDs in my array. And now at the end of all this, if I double click, here we go. It brings it in the middle. Yeah, there's of course there's so much more I would like to show, but so little time. There are a whole bunch of more interaction handlers, so they're all documented here. So for example, you can links to the documentation page. You've got a box select interaction. Also for click has a whole bunch of different callbacks, so you don't have to implement click interactions, basic ones from scratch either. That will come here. We've got lasso and hover. Just to show you what you can do with it, how we've used it so far. Here in query, very similar. We've got selecting through clicking. I believe double clicking does expansion. There you go. We should fit the node similar to how we did it just now. That might be nice. Yeah, explore works in a very similar fashion. So here again, NVL in action. Dragging, double clicking in our case here does the inspector. Get a context menu for expanding. Yeah, so this is all done with NVL, including the minimap here. And one thing I also want to show finally that I think is really cool, it's something in a very nifty interaction that the data importer has been working on. So these are all individual NVL instances here. And if we create a graph model, so this is also NVL in action. There is a very special interaction that they built from scratch where you, depending on where the node hovers, you can see this little visual feedback. And then if you start dragging, you can create new nodes or new relationships this way, which I think is really cool. So this is also something that's built completely with NVL. The idea really is that we can, it's not so much a graph exploration app that works out of the box, especially if you just use the base library. It's very much a toolkit to build your own graph application in whichever way you would like to build it. Yeah, and that's all I have to show for today. I'm really excited for everyone using NVL. So please feel free to go to NPM and start using it with Aura. You can just set up a free instance there and get started. And yeah, please reach out with any questions you might have. Thank you very much.